In this video, I'm going to show you how to compute a confidence interval for means and perform a hypothesis test for means. Before we begin, let's take a look at the data set that we'll be using today. We'll be using our very favorite sashelp.cars data set. So let's take a look at that data set right now. Under Libraries, My Libraries, sashelp, and we'll take a look at the cars data set. I'll maximize my screen. And remember, we're computing both a confidence interval and performing a hypothesis test for means data. So that means the data that we're working with has to be quantitative. So today we'll be working with the column MSRP, and this is the manufacturer's suggested retail price of the vehicle. So suppose we want to be able to compute a confidence interval for the manufacturer's suggested retail price of an automobile. Now, of course, we only have a sample of cars. In fact, we have 428 cars in this data set. I think you would agree with me that this is not every car in the world. So we have a sample of this particular type of data. It's 428. And we want to say something about the population using the sample that we have. So we want to compute the confidence interval for the MSRP column and then say something about the entire population. So let's go ahead and compute the 95% confidence interval. And you'll remember that you can have a confidence level of 90, 95, or 99. Those are the three most common. You can technically have a confidence level at any level, but 90, 95, and 99 are the most common. So we'll return to our tasks. And for confidence intervals for means, we're going to take a look at the task under Statistics, and we're going to use the Summary Statistics task. I'll maximize my screen. So I'm not using the datasets.class data today, so we'll be looking at sashelp.cars. All right, and the analysis variable we're working with is MSRP, which is the first variable. And now we have to change a couple of settings to compute the confidence intervals. So we'll go on over to the Options tab. Under Additional Statistics, one of the options here is confidence limits for the mean. So we'll click on that. And then you'll see in the drop-down box you can choose 90, 95, or 99, or you can actually type in a custom value that you would like. We're going to compute the 95% confidence interval for this particular column. So I will run this task. So you'll see here we have some output from the task. First of all, we have the mean of our sample. So this is our sample mean, or Y bar. We also have the standard deviation, which we could use to calculate the margin of error if we wanted to do this by hand. But we're not doing this by hand, so here you will see we also have the lower and upper 95% confidence limits. So the lower confidence limit for the MSRP of a car is 30,928.69, and the upper confidence limit is 34,621.02. So you would very nicely state that we are 95% confident that the mean price, or the mean MSRP of all vehicles, is between 30,928.69 and 34,621.02. So remember, when you're stating your confidence interval, you're stating a confidence level, you're stating about the entire population, and then of course you have to state your lower and upper limits for the confidence interval. So of course, if we wanted to compute the 99, we simply just change this confidence level to 99, and we rerun the task, and you are not surprised that these confidence limits, the lower one just got lower, and the higher one, or the upper one, just got higher. Of course, the confidence interval widens as we want to be more confident. So not to be exhaustive here, but if I go ahead and calculate the 90% confidence interval, then that interval narrows. So now I'm going from 31,226.54 to 34,323.17. Okay, so that's confidence intervals for means. Now let's say we want to perform a hypothesis test. So I'm going to get my tasks back. So let's set up a situation. Let's say that historically, the average price of a car in America is about $30,000. And we want to see if, based on our sample, if that has changed. So the status quo, or what we currently believe to be true, is that the average price of a car is $30,000. And we want to see that based on the sample we have of 428 vehicles, do we see that that's actually true? So going back to the mechanics of how a hypothesis test works, the fact that we currently believe the average price or the mean price of a car is $30,000, that is our null hypothesis. Our alternative hypothesis is either that we just want to check to see if our sample indicates that that has changed in either direction. In other words, have cars either gotten more expensive or less expensive, or we might want to compute a one-tailed or a directional hypothesis test. Maybe want to check if car values or car prices have increased and we don't really care if they've decreased. So again, your alternative is going to be based on what you want to find. So let's go ahead and set up a hypothesis test for means. So the task you're going to use for this is the t-tests task under statistics. I'm going to maximize my screen. We're using sashelp.cars again. And here you're going to be asked under the t-test dropdown whether you want a one sample test, a paired test, or a two sample test. In this particular situation, because we're currently studying one sample t-tests, we're going to select one sample test, which is already selected for you. We're going to pick the column that we want to analyze, so it's still that MSRP column. And now we want to go ahead to the Options tab to set up the actual hypothesis test. So you'll notice under the tails dropdown, you have either a two-tailed test, an upper one-tailed test, or a lower one-tailed test. And the option you pick really depends on your test that you want to perform. If you're interested in changes in either direction, so for example, we believe currently the MSRP, average MSRP for a car is $30,000. Well, if we want to see, does our sample show any differently in either direction, then we would do a two-tailed test. If we're interested in testing to see if car prices have increased, then we would do an upper one-tailed test. If we're interested in finding out if car prices have decreased based on our sample, then we're going to do a lower one-tailed test. Let's just keep things a little bit simple. I'm going to perform a two-tailed test. And then the next thing you have to fill in here is what is your null hypothesis? What do we currently believe to be true? And I told you earlier, we currently believe that the average price of a car is $30,000. So we'll type in mu is not equal to $30,000 because this is our alternative hypothesis. So our alternative right now is mu is not equal to, that's the symbol for not equal to in SAS, not equal to $30,000 because it's a two-tailed test. If I were to change this to an upper one-tailed, you'll notice that that changes to a greater than symbol. And if I were to change that to a lower one-tailed, that changes to a less than symbol. But I want to do a two-tailed test, and I already have $30,000 in there. So when you're all set, you just go ahead and run it. And once the task runs, you will get the output you need. The output you're looking for is right here, where you're seeing the PR is greater than absolute value of t probability here. So this is your p-value. So my p-value here is 0.0033. Now, if we're using the traditional alpha level of 0.05, which is usually what we cut off at, then in this case, I am going to reject my null hypothesis because my p-value is lower than 0.05. So what does that mean for this particular situation? That means that based on our data set, it looks like we have statistically significant evidence to no longer believe that the null hypothesis is true and that the alternative is plausible. So right now, the fact that history says that cars are $30,000, we're generally no longer believing that. We have enough statistical evidence to no longer believe that. In fact, if you take a look at our Y bar, which we got earlier, it's 32,774. We know that that is indeed different than $30,000, but this test tells us, is it statistically significantly different? That's what we want to find out. So again, in this case, because our p-value is lower than 0.05, we reject the null hypothesis. Therefore, the alternative hypothesis that the MSRP is not equal to $30,000 is plausible. Of course, you would set this up pretty much the exact same way if you were doing a one-tailed upper or a one-tailed lower, and you would interpret the p-value the exact same way when you're computing those hypothesis tests. That's all for today, and thanks for watching.